Good afternoon. This is Mars. It's a particular place at Mars. It's called the Gale Crater. It's a great image that I like. It's made of satellite imagery that's been put together and assembled to make a digital elevation map. The crater is seen at the edge of this image is the rim of the crater. And in the center is a massive mountain, Mount Sharp. Stands 15,000 feet tall. For those of you who will recall, that's taller than anything in the continental U.S. Well, now, down there, in the shadows, between that massive mountain and the crater rim, there sits a rover named Curiosity. And it was my distinct honor, in fact, the greatest honor of my life, to lead the team that landed her there. But my story doesn't start here on Mars. It starts here. Actually, here. Really here. This is an image a friend found online for me. It's from the Marin, which is not very far from the house I grew up in. And although you can't really quite see it right now, the constellation of Orion is hanging there over the night sky in the Bay Area. I was in my 20s, early 20s, 20, 21, and I was playing music in the Bay Area and gigging, and I noticed, I really had clearly not noticed much during high school, that when I was returning from playing a show, the stars were in a different place in the sky. And the constellation that I noticed was Orion, although I had not paid attention ever enough to know that its name was Orion, but it's a big boxy structure, and I remember somebody telling me about that little fuzzy thing in the middle. And so I noticed that I let my curiosity about that motion of the stars in the night sky lead me here on a whim, on a serendipitous event. I got in my car from my apartment in Mill Valley, and I drove over to College of Marin to see about taking an astronomy course, because I figured I needed to learn about why the stars were moving. And I came in, and I ended up showing up on the day that the classes were being filled, that you could sign up, and back in that day. That happened in a big gymnasium, and they put a list of the classes with several, lines, and if you got your name on the list, you were in the class. I go to the astronomy page, and I notice that there's a co-requisite of a physics course, a conceptual physics course, it calls it. I think it may have been Physics 10, I'm not quite sure. But I took that course, and Stephen Prada, who's not here today, but was the professor, blew my mind. He had the ability to communicate to his students the glee, the excitement at the prospect of understanding our world. He certainly communicated to me. It was infectious. And that caused sort of continued combustion in my curiosity. And I decided that I wanted to learn more about physics. And eventually engineering, because that was physics for people who wanted to get paid. And it made a big difference. If old Ad, that's me right there, growing out a mohawk that I've been wearing, if old Ad had been asked to do new Ad's job, his head would explode. But somehow, thank God, we never really know where our curiosity is going to take us. So I want to talk a little bit today about curiosity and exploration and the edge of us as individuals and as people. Curiosity is the spark, and exploration is the fire that burns from that spark. The investigation, the science, the act of the verb that follows the curiosity. And the edge of ourselves is sort of the flame front. As far as that fire has burned is the edge of who we are. In some ways, my life has got a pair of parallel arcs that have to do with curiosity and exploration. There's professional life, which has the arc of landing curiosity, which has got a great double entendre, and that she is sort of the embodiment of our curiosity, but landing her on Mars. But also the arc of my personal life, and what happened when I allowed my curiosity to take me here to the college planet, and allow me to be open to learning about my world. So first, let's talk about Mars. We've always marveled at Mars for millennia. From the before telescopes, we would look with the naked eye and we'd notice a fuzzy, oranger, red-colored object in the night sky that didn't move exactly like the rest of the stars in the background. Eventually, we got telescopes and we looked at the planet and we knew immediately that there was life on Mars. We saw canals and roadways and landing strips. And we've been trying to shape the idea that there might be life on Mars ever since. We've been sort of captivated with the possibility that that's the case. Not only because of what it might mean for Mars, but what it might mean for us. Are we alone in the universe? Are we alone in our solar system? How unlikely is life, this life that we see here? We went first to Mars, to the surface of Mars, successfully in the 70s with Vikings 1 and 2. And these were fixed-legged landers. I call them legged landers. Can we come back to that? Tripod-legged, milk stool landers that would touch down and investigate the region just around where they were. We put 2 of them down, and they looked for life, and they didn't find it. And that discouraged and blunted our curiosity, and it would be 20 years before we would return to the planet's surface. When we did, we took a little tiny rover, 1997, the Sojourner rover on the Mars Pathfinder mission. This mission was interesting. It was almost a bit of a lark. Viking, well, the beauty is, back then we didn't keep track of how much money we were spending. So we don't really have a good number for what Viking cost, but it probably was in the $5 to $10 billion range in today's dollars. And in '97, we were experimenting with a mode of operation in NASA called faster, better, cheaper, where we'll embrace tastes great and is less annoying, but then embrace risk. And really, this mission to the surface of Mars with that little tiny rover was trying to ask the question, how inexpensively could we get to the surface of Mars? Well, we spent about $350 million, which is much less than a tenth of what it costs to put Viking fixed landers on it, and we had a little vehicle that could roam around. Buoyed by that success, we would return to the surface of Mars in 2004 with a pair of twin rovers. I helped work on those, and that pair of rovers, Spirit and Opportunity, they looked for signs of water on the surface of Mars. And they found signs of water on the surface of Mars. Now, why is that important? That's important because we know here from here on Earth that where we have water, we frequently have life. And where there is no water, we do not find life. So they found the evidence of water, but the instrumentation on Spirit and Opportunity didn't allow us to understand much about that water. Whether it was capable for being used by biological organisms, the salinity, the pH. In short, was it a habitable, wet environment in the past of Mars? So enter Curiosity. She's 900 kilos, 2,000 pounds, as big as a car. She's packed with all of the instrumentation that you would imagine to be able to answer that question of if there is life. But she's big. And to put her on Gale Crater, we are going to have to do a much better job than we've ever done before. So this is an image of Gale Crater again, now seen in shaded relief. So the orange is high, the blue is low. And you can see sort of an orange-green ring, that's the crater rim, and you can see in the center Mount Sharp. The altitudes look a little weird here. That's just because of the reference that we use at Mars. Those ellipses are the uncertainty footprints of our landing, where a spacecraft may land when we target the center of that ellipse. We call them ellipses because they're elliptical. I've plotted here all of the uncertainty ellipses for all of the successful expeditions to the surface of Mars. Period. And you can see starting in the 70s with Viking, we had a lot of uncertainty. We slowly ranged it down. But to land in a flat spot between that proverbial rock and a hard place down at the bottom of the Gale crater, we were going to have to do substantially better. And when we got down to the surface, we were going to have to land something that was really, really big. If she were here today, it's fun to be in her presence. It's slightly intimidating. Literally it is, because that mast sits 8 or 9 feet above your noggin. And it looks sort of, everybody sees a different face in this. Some people see a pair of eyes down low. Some people think of a single monocle eye. That big pink monocle there is a laser that can evaporate the surface of rocky material from about 30 feet away or so, and then look at the vapor that's released and do spectral analysis on it and get a clue as to what the rock is made out of to see if you want to actually take the time to drive on over there and do surfacing. So she's an intimidating, large, death ray equipped beast. And landing her was hard. We looked at an array of different techniques. So that little tiny rover sojourner and the twin Spirit and Opportunity, we landed the landing system, the final piece, the final embrace with the surface, was handled with airbags. But Curiosity is so big that we don't have fabrics that are strong enough to allow us to make airbags work for Curiosity. Humankind does not have the technology. We thought about legged landers, like Viking. Imagine just sticking a big rover on the top of Viking. In 1999, we lost the Mars Polar Lander, which was a mission to the surface of Mars using a legged lander. And in the process of doing the analysis, the failure analysis, we really rediscovered how sensitive legged landers were to slopey terrain. And turning over because of slopey terrain. So you put a big fat rover on top of the legged lander, and it's very, very sensitive to slopey terrain, so that was out. We tried to fix that sensitivity to slopes by squishing the lander out, giving it 6 legs, really squat. Unfortunately, that pressed the propulsion system, filled with usually explosive fuels, right down against the rocks. And exploding on landing is considered extremely poor form. So that was out. In the fall of 2003, facing dead ends in all of these other families, we gathered everybody together, sort of a brain trust of folks who had worked on systems like this at the lab. And we sort of poured out onto the table in a great 2-day brainstorming session all of the ideas that we had in the past. And sort of like try to collage them together, cut and paste, see if there was something that we discarded in the past that we could use, or that we discarded in the past that with some new information or a new way of looking at it, we could use in a new way. And out of that came this improbable configuration called the Skytrain. And let's see how it went. Some of you were missing in action in August of last year. Here's a reminder.
It was at your face. At this time, the pressurized propulsion system to increase the thrust of the system. We use that for voltage over gas or oxygen.
alternative night. Far better than the alternative. From that night, this is my wife Trisha's favorite picture of me. It's also my favorite picture. Because this is me looking at this. The ones and zeros, the information that comes down that tells you analytically the vehicle is safe, that it's landed, goes into a different part of my brain than a new image of a new place in our solar system. That is the result of an effort of people coming together and working. This is the big payoff for me. It has been in each of the expeditions to the surface. That first visceral perspective on another place. So she's happy and healthy, and she's doing fantastic science on the surface. Thus far, she has found a riverbed that had water flowing through it for millennia. This is important because Spirit of Opportunity previously had told us that the surface had been wet, but did not tell us for how long or the conditions that the water had been. Well, we know it had been present for a long period of time. That's important for the possibility of life evolving. And since discovering that riverbed, she's drilled into the surface and looked at the mineralogy there and concluded that the primitive environment on Mars, the wet primitive environment on Mars, would allow life to exist if life had existed. So she's doing fantastic science. But I'm left with one question. Why do we really do this? Is it strictly about the science? This is an image of a few thousand people, all of us here on the West Coast, we landed on Sunday night, August 5th. But for people who live in strange places in other parts of the world, it was Monday morning, the 6th of August, at 1:30 in the morning, and there's thousands of people in Times Square watching on the big diamond screen. Now, are they there because they're dying to know about the pH and salinity of the primordial aqueous environment on the surface of Mars? They're not, or they may be, certainly there because of that, but I think they're there at 1:30 in the morning for a little something more. It may be akin to when thousands of folks watch an athlete trying to do something a little faster than another athlete. When we explore, we're asking questions about ourselves, about who we are. What can we do? Neil Armstrong hinted at it with the words he chose to say upon setting foot on the moon. One small step for a man, one giant leap for mankind. He was telling us that with his exploration, he was dragging us, carrying us with. We were all becoming a little bit more with that act. When we explore, we're asking questions about humanity. How grand are we? How bold are we? What questions might we dare ask and hope to answer? How great is our reach? Now, there are great challenges in front of us at NASA. There are, we can pack all the ingenuity that we might perceive ahead of time into that rover Curiosity. But that cannot touch the ingenuity we can bring to bear across the planet. Ultimately, we will probably have to bring material back from the surface of Mars, perhaps to unlock that question about the existence of life or the possibility of life. And there are other places to go. There's a Europa, the icy moon of Jupiter. It's got a crust of ice, and we believe it has a water ocean in it, heated by the tidal motion of Jupiter, tidal stresses within the body. I am no exobiologist, but I do drink beer with them. And they all think that this is the place in the solar system most likely to have existent life today. So I want to leave you with this image and tell you that for me, it feels different. And it feels like a physical manifestation of an arc in my life that started here at the College of Marin. When I allowed the curiosity that I experienced looking at the motion of the stars in the night sky to drag me here and to see where it might take me. I think that the community colleges are unique in being a safe haven for people like myself in positions that I was in. There's no way I was going to get into any four-year college. I barely graduated high school. I only found out I graduated high school, by the way, many years later, after I transferred from College of Marin to UC Davis. On my College of Marin transcripts, it noted that I had graduated. I didn't want to go back to Tam High because I was fearful that the diploma wouldn't be there. So, the community college is a unique place. It allows second chances. It allows, I don't even like the term second chance. It allows new growth. It allows new opportunity within the minds of us. And so, I thank you for being able to be here and celebrate the building and come back to this place where my personal arc of curiosity started. Thank you.